Hello, welcome to my channel. Today we are going to talk about a very interesting topic in engine programming that is called multi-threaded application context rendering. At first, we have to understand how game loops work. So a game loop is a loop function that goes on forever, and it takes inputs from your user or network based on your multiplayer or single player, and it processes the input, so it applies to the word your player move objects around and etc. And after that it outputs the actions based on your input, closes the window, play audio, graphics, etc., or maybe send packets if you're in multiplayer. So, what is a sequential game loop? The sequential game loop is mostly used in hobby and educational projects, in which the actual subject is more important than the game engine itself. So, for example, in educational projects, you're learning about graphics, and hobby projects for learning about the language base. So, in which we are ignoring the threaded game loop, and we will just make a very basic single-threaded sequential game loop, so we can structure and render everything that we want. So, what is the downsides of a game loop that is sequential? The downsides of sequential game loop is basically the blocking in the render pipeline. So, if we call this a render pipeline or the loop, anywhere everything can block. Like for example, if you're polling window events, your window could be in a modal loop and could be unfocused or could be anything else. So what happens to the window? It will make a barrier, so it doesn't let other functions run, and it make your frame goes beyond the limits and make your delta time going very high. So you have a very big delta time and very big lag in your game loop. So you either need to limit your delta time or maybe try to get rid of this blocking effect. So the modal loop is basically where the window enters the resize or move state in Windows or in X11, and in Android it's basically about like moving your phone, rotations, or maybe unfocus your window, or maybe it's running in background. So the poll events will it's actually called poll commands. It will actually cause a very bad block in your render pipeline or your render loop, or maybe the game loop, let's call. And what this does, you will lose audio, your audio runs out of the queue, so your stream gets lost, so you don't hear anything, and you lose physics. You also break physics because your delta time is very big, and you also break various stuff. It could also be in the opposite way, like you're presenting the back buffer, and in this stage the graphics are responsible for doing stuff. So if your GPU is busy or your GPU cannot handle more than like 60 frames, then what happens is very obvious. So your loop is lagged, and it will also cause you to delay. Your loop is delayed, it will cause you to get delayed window events. What is delayed window events equal to? Input lag. You're right. So now we understand how we can produce input lag and how we can bottleneck GPU and CPU together when everything on a single thread. So what we should do about it? What is the solution to this? Yes, you guessed it right. Multi-threaded game loop, in which every thread owns the context, creates and owns the context, and also applies the actions in the context. And based on the shared data between them, there is no more problem with synchronization and blocking issues. Let's talk about this in detail. As you can see, we have a code base here, a very quick example, a very basic example of how this works and how we should use these classes and get the advantage of the threaded application context rendering, the aka multi-threaded game loop. As you can see here, I have audio implemented, and I have GL, OpenGL in Win32 application, and also OpenGL render context. And I also have very basic utilities of C++, like for curl node for time, delta time, an IO stream for output, CMath for sine function, for RGB effect, RGB colors for the background or application, and also memory for basic, basic ownership and RAII code style, and also UniSTD for a sleep, I believe, or maybe for, wait, let me see, what's that used for? Yeah, no use case for that, by the way, never mind, that was junk. So, and these are just basically the width and height of the window, and this is the RGB scroll function. This is a very basic RGB function which scrolls around the RGB circle by adding the T by 120 degrees and 240 degrees. So that way you have like 3 points on a circle, and you just you take away a little bit of that, a little bit of green, a little bit of blue, and it just circles around, the sine function, how sine function works. Yeah, just like that. And by the way, we are also converting that to 0 to 1. So, sine has -1 to 1, sine is -1 to 1. So we are actually converting it to 0 to 1. So we're sampling basically based on the sine function. We also have this code which creates the audio context and stream Vorbis player. So we need to tick this stream Vorbis. If you don't tick it, because it's a tick adapter, your music will run out of queue, and you will just stop hearing the music. Or if you take it back, if you take it after that, you will start hearing again. But you don't want a very choppy music effect where you stop hearing and start hearing. It's very bad. So you also have a very small example for how to load the music file and how to load the WAV file. You're of course not playing it, because we are going to talk about the threads, not audio. And this is where the actual thing lives, or we call it the concept. So using that class, using render thread context and application thread context class, we start the application. Then by using condition variables not asleep, we will wait for the application to start. So once started, we can get the context without any worries of null pointer or maybe race conditions. So we already know that we created the context, and we getting that after the context creation, so it won't be null pointer or any undefined behavior. And we also push a constant work for the rainbow color on the screen using the delta time atomic float. So be careful of using outside the scope functions, because as you know, this is not going to run instantly. So if you go out of scope and whatever it's here gets destroyed, you have to be very careful of ownership. This is just a very basic example. So we have to implement ownership, and we be careful with captures here. So you either have to pass them by value, or if you really care about memory and stuff, you have to move or transfer the ownership. And here goes the start graphics function, which we are basically doing the same thing, but for the GL thread, and we are passing the app context pointer, and we know that it's already running, so there is no problem of null pointer dereferencing, but still we check if it's null pointer or not, and we create the context. So if we fail to create the context, we just print error and return null pointer. So after that you can just check if it's null pointer, you just don't continue because we failed to create the context. Then we just start playing the music stream, and once we started, we get into the main thread loop in which there is no ownership, there is nothing. We can just use the stuff and enqueue functions and work with them perfectly. So here basically we take the shared events between application and between application and GL thread. So application just creates and pushes events to this app state, this shared app state. So what is a shared application state? It's basically consists of application data and synchronized safely. So you can just take them anywhere and work with them and be sure that it doesn't break, because ensure it doesn't break because it is synchronized and it has mutex locks, so it doesn't break. And we basically just check for the event. If it's window resize, we will push a task, a very temporary task, and careful, notice how I'm pushing by values, not by reference, because these two brothers will be invalid because we are going out of the scope. So if we go out of scope, then the variables that are allocated in the stack will be deallocated, and now we have undefined behavior in the captures. Basically we do GL viewport to change the viewport, and then we also have in 10 milliseconds sleep for safety so we don't break things, and we also take the music stream so the music keeps playing without using the full memory. And the cleanup is very obvious. It is just stopping the thread, and by stop it means joining in the stopping. So this is different than this is by default is joining and stopping. So it basically stops and waits for a stop by condition variables, and once waits, it checks if the geo context is available, which is, because we already checked it back then, it shuts down the context and also the application context. Let's run the code and see what happens. As you can see, we have audio, which is very good. We can move the window. While entering the model loop, we can see the window change color. It means we are already rendering. And same with width and height. As you can see, we are sending messages to GL viewports and changing the viewport of our render without anything blocking the window and rendering. And there is also another thing that you have to notice. We have MSI Afterburner, and by pressing F11 we can examine the CPU usage and graphics usage. As you can see, one of the threads are pushing really hard. What this means is basically the swap buffers function is working really quickly. It basically races with CPU. So swap buffers include the block, but it's very little that CPU cannot go above that. So what happens? You have 4000 FPS capped by the respect to the CPU bottleneck, but this is not the bottleneck because of the code, because of the hardware. So this is very good, because as you can see we have 45% of GPU usage, but if I increase the window size, the GPU percentage usage also increases up. So what this means is basically our application now puts more load onto GPU, but still CPU cannot hit that because GPU is not already full. So pretty cool, huh? But we have less frame rate now. Thank you for watching my video. Be sure to hit like and subscribe button for more fun content. Happy New Year!